Okay, quantum computing, I guess it's often seen as a fairly distant concern, but Q-Day, when quantum systems can break today's encryption, maybe is going to arrive a little bit sooner than expected. So can you give us some idea of how real is the threat, and is there anything that organizations should be doing right now to prepare for it?
Yeah, so the threat is real. I can tell you that in the sense that we know that for a number of reasons. We know that quantum computing has been taken in the lab environments to the extent where some of the protocols that we use as standard protocols today have already been tested against some of the early quantum computing that we've built and shown that these encryption methodologies can be broken. And so while we don't have a commercially viable quantum computer today that can really do that, the question isn't so much a matter of whether we will, but when will it happen? Now, in terms of when it will happen, there are a lot of different theories about that. There are, our company tends to place it around 2030 is what we generally advise our customers. But many people believe that it's going to be before that, and many people believe it's going to be after that. I was recently at a quantum computing conference where the attendees were many people were polled, like quantum scientists that are working around quantum computers were polled, and they asked when the dates that they thought that this was Q Day, as we call it, is going to be here. And there was actually 15% of them who said that they thought that Q Day probably is already here. We just don't know about it. That it could be that implying that state actors may actually already have quantum computers, and they're just not telling the world about it. And so that's one possibility there that we got to take into account. Another thing of the reason why thinking about this issue now, as opposed to just waiting until down the road when you hear some kind of an announcement out that that Q Day is here, is this concept around harvest now, decrypt later. And so this is a concept that even if you don't have a quantum computer that can break these algorithms now, or encryption algorithms now, then you may have data in your organization that has a kind of lifetime of value to it. So when you think about like health records or communications, things this data may be encrypted and unbreakable right now, but if you can download and take these or exfiltrate these encrypted files now and hold them for a couple of 3 years until a quantum computer can break these codes, then you can decrypt them later, and the hackers would still find great value in that information, even though it's 3 years old. So that's another reason why companies need to start putting some thought into this now, because and thinking about their data structures and what the implications of quantum computing will be in the future.
Okay, and in terms of the technology that's being developed to address the threat that you've outlined, perhaps you can tell us a bit about post-quantum cryptography and also quantum safe networking. I guess there's different topics, but tell us a bit about those. And then I guess if they come together, is that the best way to protect data in a quantum ready world? Yeah, just describe us that sort of infrastructure if you can.
Yeah, sure. So in regards to post-quantum cryptography, I'll tackle that one first. So we believe that when quantum computing really becomes prevalent, that many of the algorithms that we have today, like RSA, like ECDSA, like DSA, are no longer going to be secure. And these are asymmetric cryptography capabilities that a lot of people, it's pretty well recognized. But even symmetric algorithms like AES are going to need adaptation whenever when Q day arrives. So what's going on in the industry around cryptography is that we're trying to get everything to the point where we are thinking ahead about what are the kind of algorithms that are going to be needed in a post-quantum world. And NIST, who's one of the standards bodies around these kinds of things, has been working on new algorithms that would be quantum safe encryption algorithms. And so far, they've published, I think there's around 3 of them that they've published, and they've got a couple more that they're working on that the industry is waiting on. But the idea is that as these quantum safe algorithms for encryption get published and for different types of applications and different uses and deployments, then the equipment manufacturers and the software manufacturers, service providers in different layers of the network, from application all the way down to network, will start adopting them and incorporating them into their products to um, basically make to shore up the infrastructure around the world of enterprises to make it safe. Now, there are a lot of things that actually can be done today. So there are some things that like at the network level, which is the area, that space that I work, we're working with a lot of the different vendors like Cisco and Nokia, for instance, on adopting these new encryption methodologies to make networks safe in a post-quantum world. We've actually done some deployments now. We can't announce the customers' names, but in the financial services space, we have done some work with some banks to start deploying optical networks that are quantum safe. So there are things that companies can do now, and that's actually one of the things that we're recommending to enterprises is to understand their infrastructure from all the way up the stack from from the application layer all the way down to the network, to understand where these improvements have been made in the technology to be safe in a post-quantum world, and what can be deployed now, and creating a roadmap for customers as to like when they can adopt what technology when to continue to shore up their infrastructure and make them quantum ready.
Okay, but I guess one of the problems that there's been traditionally with sort of IT in the enterprise is this idea of silos where everyone sort of looks after their own little area and maybe doesn't think of the implications or how it integrates with other areas. So how much of a problem when it comes to quantum, and we've obviously got AI, cloud network, of storage, I mean loads of different things going on. How important is it that all those people are on the same page, if you like, when it comes to understand what's, as you've explained, the implications of Q Day and how to help address the challenges, if you like.
Yes. So you got to think about it in a couple of different areas, and the way that we've seen enterprises approach this. There is thinking about the implications of quantum from a security standpoint, and there's thinking about the implications of quantum from a business driver standpoint. And what I mean by that is how is an enterprise, what opportunities does an enterprise have to use quantum computing to do new things with their business, to improve their business, to launch new products, to more accurately forecast data, whatever types of business, like if you're in the financial services business, understanding what trades to make. You could use quantum in a proactive way, and then there is preparing for quantum in a reactive way or secure from a security standpoint. For that security aspect of it, what we really see is that the CISOs of organizations are kind of taking the lead on that in terms of uh, uh, getting an understanding of what the threat that's posed by quantum and how that works across the entire IT infrastructure of an enterprise. And the CISO is really, we see them mainly taking the lead in doing that and then driving that across all the different silos of the organization. I think the point that you're getting at is, though I think is very valid, in that the way that so many organizations are set up, where you have technical specialists in different areas, and they work for different managers that roll up in different silos in the company. That the danger is that if the CISO or the CIO does not kind of recognize the threat of quantum and take the lead and start looking at the implications of it across their IT infrastructure, then you're going to have this inconsistent way of preparing for it that's based upon just what each individual silo thinks for their part of the IT stack that they manage. And that is going to be that would be a really bad outcome in the end, because it's also interrelated that if you don't take a thoughtful approach across the entire stack and think about the implications of the interfaces between each one of those different layers, then you're going to have flaws and holes in your strategy around how you prepare for this. And so that is one aspect is when you think about quantum security, that's really the things that enterprises need to think about. On the other side, it's a little bit of a different problem in terms of adopting quantum computing in your business to actually do new things with your business, to make you more competitive, to make you more accurate in terms of the products that you build. For instance, in the insurance industry, you could, I've talked to insurance industry executives who think that quantum computing is going to enable them to create insurance policies on a much more targeted pinpoint level. I mean, you could think about the future where, Philip, you've got your own customized insurance policy that, just for you, that nobody else in the world may have, and it's specifically optimized just for you. That's the kind of thing that potentially you could do with quantum computers, and deploying that into an organization really involves a different range of silos and companies, from the marketing aspect, the product management perspective, the development perspective, and so it kind of depends upon which of those two areas that you go down. What I think we see most of the work being done now is around those that are concerned about the threat that it poses to current encryption methodologies, and so it's primarily, I would say, being led from the CISO side of the organizations today.
Okay, and clearly quantum computing is one of several sort of current innovation. I mean, AI automation more generally is also occupying folks' time. So is it, and everyone recognizes the sort of more complexities being added to the overall sort of IT landscape, if you like. But is it possible for IT leaders to somehow simplify their environments without slowing down the innovation that these new technologies offer, or do you just have to shrug your shoulders and accept that by leveraging the advantages they bring, you're also going to add a significant amount of complexity that's going to have to be managed?
Well, I do think that what we're seeing is that there does have to be a big adaptation that has to take place over the next couple of few years to take advantage of AI and to take advantage of quantum as both of these technologies kind of come crashing ashore at relatively same time frame. And one of those things is around that's common, I think, across both of them, is really establishing a solid data foundation. Is how we describe it in our company. It's making sure that you are creating a data structure and a data foundation that allows you to pull all of this massive amount of information that can be collected from the various parts of the company to get it in a repository that enables you to have accurate information and timely information that can be distributed to whatever platform it is that needs to consume it. So when you think about AI, an AI that is tuned to a individual business is not something that you're going to just be able to buy off the shelf from, hyperscaler. It's something that's got to learn the unique characteristics of your business So, for instance, that insurance company example that I just talked about. If you think about what it would take for an AI to go and learn from all of that years and years of information that an insurance company may have about things about where a person lives, what are the health conditions in that particular area, what are the lifestyles, what are the eating habits, what are the the risk factors, what are the pollution, how's the weather impacted. I mean, so much of this data that can all be influenced, and the more data that you have, that you can give an AI to learn off of all of that and over an extended period of time, the more accurate that it's going to be. But if you don't have that data foundation really laid out well, then you're not going to the AI that you train is not going to produce the good accurate results that you're going to want it to produce. So that's a big part of it. Another part of it is around the framework that you set up for building AIs, and particularly around the agentic AI space, where if you want to exploit that in your company, it's going to take a really a new type of framework that most companies don't have today, that involve building out AI agents in a way that are composable, that are interoperable, and that can work together in various ways. And when you think about the complexity of that, that is a very complex problem. It's these you got to think about how AIs can be used together to and work together to create an outcome for you that spans many different parts of your business, and has to cross many different parts of your business. So that's a way of operating that is really a new way of thinking, in a different way of approaching things that enterprises just don't have set up today.
Okay, and in terms of the work that yourselves at Kyndryl are doing, I think you're working with Cisco, amongst other things, in helping customers building the secure, scalable infrastructure that's needed for, I guess, both the AI we talked about and also quantum computing. So, can you just give us a little bit more detail as to what it is, the work you're doing with them?
Yeah, so we're working with Cisco and with other of the networking vendors on their strategy around quantum and AI. And I'll tell you, it's really exciting stuff. It's actually, I think it's one of the most interesting and fun parts of my job, is to be working with these companies like Cisco on what they're developing, and providing them feedback and information about what we see from our customers and the problems that we deal with, areas that they can help. And what's really great about that is that so, for instance, with Cisco in the quantum space, they're the shoring up the global infrastructure around network for to be quantum safe and to be ready for Q-Day is not a minor task.
Yeah.
So you think about all of that embedded infrastructure, and Cisco, think about it, the Cisco is really one of the largest around the routing and the layer 3, the internet infrastructure around the world. And when you think about all that embedded infrastructure, and what do you have to do to make that quantum ready, the immediate fear that comes to people's minds is, oh my gosh, am I going to have to rip and replace everything with new equipment to make this thing quantum ready and quantum safe? And the good news is that it looks like the answer to that is going to be no, but not completely no. In our discussions with it, I won't name names on the different vendors because I don't want to, they should represent themselves and speak to that more accurately than I would. But generally, what we're seeing is that there is going to have to be some equipment that needs to be replaced. Particularly older equipment is not going to be ready for the adoption of some of the new encryption methodologies that are going to come out. But much of the infrastructure will probably be solved with software upgrades that incorporate the new encryption methodologies. And so guiding that as we enter this phase, helping our customers understand what the options are, and guiding them through that decision-making process, helping them understand what is the trade-offs between deploying new equipment versus upgrading old equipment versus, what does an investment plan look like over the next few years to introduce technology in a way that's not one big, big bang of investment in a scramble to, deploy everything and rip stuff out all at once. That's the stage that we're entering now as an industry, and we're the role that Kyndryl plays is really helping customers to understand all those different alternatives and build a plan that is customized for them, help them do that in a way that smooths out the investment trajectory over the next few years and does it in the most cost-effective way.
Okay, and maybe just in finishing, and I suspect folks have worked out, as we've been talking, some of the important things to consider and to do, but perhaps you could, sort of summarize in terms of what a quantum-ready, AI-optimized enterprise might look like, and also some of those practical steps that CIOs should be taking sort of pretty much now in order to make sure that they're ready for Q Day, and I guess obviously somehow in combination with the current AI explosion they're sort of already wrestling with, and then Q Day arrives as well. So
Right.
just your thoughts, yeah.
Yeah, so what we are recommending to customers is we call it the quantum safe journey. And the first step in that journey is really to start raising awareness across the organization, because what's another fun thing on my job is that I get to talk to a lot of CIOs and CISOs, and the range of people's opinions around quantum are very wide. Some feel like, oh, it's a bunch of hooey. It's nothing. I'm not going to worry about that for another few years. I got bigger problems bigger fish to fry right now. Others are very, taking it very seriously. And so the first step is really just raising awareness across an organization about, having an opinion as a company. How seriously do we take this? When do we think that, Q Day is going to come? And what are the implications of that across the company? Then the next step is really performing a what we call a cryptocensus, which is building an inventory of all of the assets that you've got across your technology estate and understanding which of those assets are impacted by quantum. Then the next step is doing a criticality assessment. So looking at all of your sources of data, mapping and categorizing all of those encryption methodologies that you're using in the areas that the crypto census pointed out, and categorizing that into different buckets of things like how important, like for instance, when I talked about harvest now, decrypt later, how much of your data, for example, is got long legs to it. In other words, it's going to be the data we have now is going to still be very valuable, 5 years from now or 3 years from now, versus data that is very transactional, and after today or after this month, it's not important at all. That creating those kind of categorizations helps you then set up understanding how big the threat is to your particular business, and then it enables you to develop a plan around a quantum safe transition plan that involves that thing that I was talking about, where you look at how do you stage investment in this over the next few years so that you're not caught behind the 8 ball whenever Q Day does arrive, and you're not scrambling to make a bunch of investments and to try to shore things up, and it consumes the whole organization because of you kind of wake up and realize that you've got some real exposures on your hands. That leads into deployments of quantum safe networks and quantum key distribution methodologies, and working through that transition to ultimately get you to where we would say that you could feel like, hey, our organization now is quantum ready and we're quantum safe, or we've got this plan now that and we've got the investment committed from the organization over the next few years to know to get us to that point where when Q Day does arrive, we can feel like we have kept the organization safe.
Okay, I mean, it's been fascinating to chat, and thank you so much for sharing so many great insights into what is obviously a complicated and sort of not well understood, I think it's fair to say, topic at the moment. So, Paul, really appreciate the time you've given me. Thanks so much.
Well, thank you, Philip. It was nice to chat.